We are going to start now the fourth lecture of chapter 5, class 11th mathematics, complex numbers and quadratic equations. In our previous lectures, we have studied about the two forms of complex numbers, representation of complex numbers. One is z is equal to x plus iota y, this is the Cartesian form, and second is z is equal to r cos theta plus iota sin theta. This is the polar form. Now the next form we have over here, it is the Euler's form, and it is using the Euler's identity. So Euler's identity is, we are writing cos theta plus iota sin theta, that is equal to e raised to the power iota theta. This is called the Euler's identity. E is the exponential function over here. So if we substitute this value in this equation, we get z is equal to r e raised to the power iota theta, and this form of the complex number, this is called the Euler's form. So if we talk about the Euler's identity, we have e raised to the power iota theta, that is equal to cos theta plus iota sin theta. Now if we write e raised to the power minus iota theta, in place of iota we are writing it is minus iota, we are basically taking the conjugate over here. So the answer we obtain, it is cos theta minus iota sin theta. Now if we add these two equations, we get e raised to the power iota theta plus e raised to the power minus iota theta, that is equal to 2 cos theta. And if we subtract these two equations, we get e raised to the power iota theta minus e raised to the power minus iota theta, that is equal to 2 iota sin theta. So from this equation, from the first equation, we are saying we can write cos theta is equal to e raised to the power iota theta plus e raised to the power minus iota theta by 2, and from this equation we can write sin theta is equal to e raised to the power iota theta minus e raised to the power minus iota theta by 2 iota. Next we have is, if we are writing a number z is equal to e raised to the power iota theta, then mod of z will be equal to mod of cos theta plus iota sin theta. So that will be equal to square root of cos square theta plus sin square theta, and this is equal to 1, and the argument of z, that is equal to theta. This theta we are saying, this is the argument of z, and mod of z in this case it will be equal to 1. The next results we have is, if we have two numbers, we are saying theta and phi, and both these numbers, these are the real numbers, and we are calculating the value of e raised to the power iota theta plus e raised to the power iota phi. So what we can see from this is, we can write this term as e raised to the power iota theta is cos theta plus iota sin theta, and e raised to the power iota phi is cos phi plus iota sin phi. So this number is equal to cos theta plus cos phi plus iota sin theta plus sin phi. This term is equal to 2 cos theta plus phi by 2 cos theta minus phi by 2 plus iota sin theta plus phi by 2 cos theta minus phi by 2. So this is equal to, this is 2 over here, so this is 2 cos theta minus phi by 2 into cos theta plus phi by 2 plus iota sin theta plus phi by 2, and this term, this second term we are saying, this is equal to e raised to the power, this whole term is equal to, we are talking about this term, this is e raised to the power iota theta plus phi by 2, and this is what we are proving over here, that e raised to the power iota theta plus e raised to power iota phi is equal to this value. Now, if we take the mod over here, if we take the modulus of this value we are having, if we take the modulus of this value, then the mod of this part, the modulus of this part will be equal to 1. So we are saying this mod is equal to 2 times mod of cos of theta minus phi by 2, and the argument of this value, we have it is theta plus phi by 2 is coming from this term. Similarly, if we try to solve e raised to the power iota theta minus e raised to the power iota phi, we obtain the answer in this form. Similarly, we can apply the formulas over here for cos of theta minus cos phi and sin of theta minus sin phi, and we obtain that the values in this form, that mod of e raised to power iota theta minus mod of e raised to power iota phi, that is equal to 2 times mod of sin of theta minus phi by 2, and the value of argument we have over here, that is equal to theta plus phi by 2 plus pi by 2. We are talking about this value over here. Next is, based upon these formulas, we have some results over here. So first is, if we are talking about this formula, and we substitute phi is equal to 0. In this formula, we substitute phi is equal to 0. So this formula will imply e raised to the power iota theta plus e raised to the power 0 is 1. That is equal to e raised to the power iota theta by 2 into 2 times cos of theta by 2, and this is our first result. In the second result, if we substitute phi is equal to 0, so this thing implies us that e raised to the power iota theta minus 1, that is equal to e raised to the power iota theta by 2 iota sin theta by 2. Now if we divide these two equations, we get e raised to the power iota theta minus 1 over e raised to the power iota theta plus 1, that is equal to, on dividing these two terms, e raised to the power iota theta by 2 gets cancelled, this 2 gets cancelled, and we are left with this iota sin theta by 2 over cos theta by 2. So this is equal to iota tan theta by 2. So this is our third result that we have over here. Next is, if z is equal to r e raised to the power iota theta, then we have mod of z, that is equal to mod of r mod of e raised to the power iota theta. R is always positive and the value of this mod is equal to 1, so we get that value of mod z, that is equal to r, and the argument of z we have, that is equal to theta, and if we are talking about the value conjugate of z, that will be r e raised to the power minus iota theta. And this last result we are saying, it is that if mod of z minus z naught is equal to 1, then z minus z naught, it is of the form e raised to the power iota theta. So based upon this, we have a problem over here. It is given that mod of z minus 1 is equal to 1. Now from our previous result, we know that mod of z is equal to 1 means that z minus 1 is of the form e raised to the power iota theta. It means z is equal to, this implies z is equal to e raised to the power iota theta plus 1, and this is equal to e raised to the power iota theta by 2 into 2 cos theta by 2. Now what we have to prove over here is, we have to show that z minus 2 over 2, that is equal to iota tan argument of z. So if we substitute this value of z over here, over z we have, if we substitute this value of z over here, we get it is e raised to the power iota theta plus 1 minus 2 over 1 plus e raised to the power iota theta. So this is equal to e raised to the power iota theta minus 1 over e raised to the power iota theta plus 1. And we have already seen that this value is equal to iota tan theta by 2. Now if we look at the value of z over here, we are talking about this value of z. From this value of z, we have the argument of z. From this we are saying argument of z, that is equal to theta by 2. So we are saying this theta by 2 is basically the argument of z. So the answer we are obtaining, it is iota tan argument of z, and this is what we have to prove. Next is, if z is a non-real complex number lying on mod of z is equal to 1. So again it is given that mod of z is equal to 1. It means z is of the form e raised to the power iota theta, and argument of z we have that is equal to theta. So the question given over here, this question, it becomes, we have to prove that z is equal to 1 plus iota tan theta by 2 over 1 minus iota tan theta by 2. We have to prove this result. So if we consider the right hand side, we are writing in place of tan theta by 2, we are writing it is sin theta by 2 over cos theta by 2. So if we take the LCM, we get it is cos theta by 2 plus iota sin theta by 2 divided by cos theta by 2 minus iota sin theta by 2, and this value is equal to e raised to the power iota theta by 2 over e raised to the power minus iota theta by 2, and this value comes out to be e raised to the power theta by 2 plus theta by 2. So that is equal to e raised to the power iota theta. And what is e raised to the power iota theta? It is equal to z. This value is equal to z, and this is equal to LHS. So we have proved that RHS is equal to LHS. Next we are going to study some applications of the Euler's form. So the first thing that is mentioned over here, this is already clear to us, that if z is equal to x plus iota y, we are writing that is equal to r cos theta plus iota sin theta. It means it is mod of z into cos theta plus iota sin theta, and we are writing this is equal to mod of z e raised to the power iota theta. So this is basically the Euler's form we are talking about, and this is the polar form, and this is the Cartesian form. Now based upon these results, we are going to prove some results over here. So first result we are going to prove is that if z1 and z2, these are two complex numbers, then mod of z1 z2, that is equal to mod of z1 into mod of z2, and second thing we have is that argument of z1 z2, that is equal to argument of z1 plus argument of z2. These results, if we look carefully over here, these results we have already proved in our previous lectures, but we will use the Euler's theorem over here to prove these results. So we start solving the value. We consider that z1 be a number that is equal to r1 e raised to the power iota theta 1, and z2 is the number r2 e raised to the power iota theta 2. So if we multiply both these values, we get z1 z2, that is equal to r1 r2 e raised to the power iota theta 1 e raised to the power iota theta 2. It is equal to r1 r2 e raised to the power iota theta 1 plus theta 2. So what we get from this is that mod of z1 z2, that is equal to r1 r2, and what is r1 r2? It is mod of z1 into mod of z2. This is the first part that we have to prove, and from this equation we are saying we have argument of z1 z2, that is equal to theta 1 plus theta 2. This power of e raised per iota theta 1 plus theta 2 we are seeing. And what is theta 1? Theta 1 is the argument of z1 and theta 2 is the argument of z2. So this is what we have to prove. Next is division of the complex number. So similarly, if we are considering two complex numbers z1 and z2 such that z2 is not equal to 0, we can write it is equal to r1 e raised to the power iota theta 1. This is divided by r2 e raised per iota theta 2. So this is equal to r1 by r2 e raised to the power iota theta 1 minus theta 2. So if we talk about the modulus of this value, modulus of z1 by z2, we get it is equal to r1 by r2. And what is r1? It is modulus of z1 divided by modulus of z2. And if we are talking about the argument of z1 by z2, that is equal to theta 1 minus theta 2. So that is equal to argument of z1 minus argument of z2. So these are the final values that we have. That is, these are the results that we have to prove over here, that mod of z1 by z2 is equal to mod of z1 by mod of z2, and argument of z1 by z2 is equal to argument of z1 minus argument of z2. Next we have is the logarithm of a complex number. So if we are saying that z is any complex number and we are talking about the value, the natural log we are talking about, it is log to the base e, we write it in this form. So it is of z. So this thing we can write it is equal to, if the polar form of this number, the Euler form of this number, it is mod of z e raised to the power iota theta. So this is equal to log of mod z plus log of e raised to the power iota theta. This is base e we are talking about. So we can write this is equal to log of mod z, and what is log of e raised per iota theta if we write the value. So this is equal to plus iota theta. So we are writing it is log of mod z plus iota times argument of z. So this is one of the values we are saying, and the generalized value, the more generalized answer in this case, that will be log of mod z plus iota times argument of z plus 2n pi, where n is equal to 0, plus minus 1, plus minus 2 and so on. So we are having this formula with us, that log of z, that is equal to log of mod z plus iota argument of z plus 2n pi. So this is how we define the logarithm for the complex number. So the next question we have is, if z and w are two non-zero complex numbers such that it is given that mod of z is equal to mod of w and argument of z plus argument of w, that is equal to pi. So if we consider that the argument of w is equal to theta, then this equation will give us, this equation implies us that argument of z is equal to pi minus theta. So if we start solving the value of z, we are writing it is equal to mod of z into cos of argument of z. The argument of z we are writing it is pi minus theta plus iota sine pi minus theta. This is the argument of z. So we are writing it is mod z, what is cos of pi minus theta, that will be equal to minus cos theta plus iota sine theta. Now what we are given is that mod z is equal to mod w. We are using this result over here. We are saying mod z is equal to mod w. So we get that this is mod w. If we take minus sign common from this, we are left with this cos theta minus iota sine theta. So this term we can write it is minus of mod of w into cos theta plus iota sine theta whole bar, this is conjugate of this number. Mod of w is a real number, so we can write it is minus mod w cos of theta plus iota sin theta whole conjugate. So this is equal to with minus sign, and what is the value of this term? We are talking about mod of w cos of theta plus iota sin theta. This is basically the value of conjugate of w, and this is the result that we have to prove, that this is equal to minus conjugate of w. Next is express this number in the form of a plus iota b, and the number that is given to us is 1 plus iota raised to the power minus iota. So to express this number, we are writing it in the form of a plus iota b. So if we take log, we are getting log of a plus iota b, that is equal to minus iota log of 1 plus iota. Now what is the formula for log of z we have studied? We are talking about, if we are taking the natural log over here, we are saying log of z, that is equal to log of mod z plus the value we have, it is equal to iota times argument of z. Now we are having the number over here, the number we are talking about, it is ln of 1 plus iota, so that will be equal to log of 1 plus iota mod plus iota into argument of 1 plus iota. So the answer we get, it is log of, what is mod of this term? It is square root 2. It is 1 square plus 1 square square root 2. It is square root 2. And what is argument of this term? We are saying tan theta should be equal to 1. So theta is equal to pi by 4. So we are having plus iota pi by 4. So the value of this term we have, it is minus iota into log of square root 2 plus iota pi by 4. Now if we multiply this term, this iota inside, the answer we obtain, it is equal to minus, this will become plus pi by 4, iota square we are saying, this will become minus 1, so it is plus pi by 4 minus iota log of root 2. So what we are getting from this is that a plus iota b is equal to this value, we are saying log of this value is equal to this. So a plus iota b will be equal to e raised to the power of pi by 4 minus iota log of root 2. So this is equal to e raised to the power pi by 4 e raised to the power iota log of 1 by root 2. Minus sign we have taken inside. So this thing we can write, it is e raised to the power pi by 4 into cos of log of 1 by root 2 plus iota sine of log of 1 by root 2. So if we have to write this number in the form a plus iota b, we are talking about this step over here, we are writing a plus iota b is equal to this term. So if we have to write this number in the form a plus iota b, we are writing this number as, this is equal to e raised to the power pi by 4 cos of log of 1 by root 2 plus iota e raised to the power pi by 4 sine of log of 1 by root 2. So this is the value of a we have, and this is the value of b that we have. Next is, if it is given that sine of log base e to iota raised to the power iota, this is equal to a plus iota b. We have to find the values of a and b, and we have to find the value of cos of log of iota raised to power iota, it is log to the base e. So to solve this result, if we look at this inner value over here, we are talking about this value, it is sine of iota log of iota, and this is equal to sine of iota. What is log of iota? It is log of mod of iota plus iota pi by 2, that is argument of iota. iota light at this point. So, the angle we have over here, it is pi by 2. So, the answer we are getting in this case, what is mod of iota, that is 1, and log of 1 will be equal to 0. So, what we are getting, it is sine of minus pi by 2. Why minus pi by 2? It is iota over here, this is iota over here, and multiplication of both these iota, that will be minus 1. So, the answer we get in this case, this is equal to minus 1. Sine of minus pi by 2 is minus 1. So, we are saying that the number a plus iota b we have, that is equal to minus 1. So, a is equal to minus 1 and b is equal to 0. Next, we have to calculate is the value of cos of this term. So, we are saying that sine of log of e iota raised to power iota is equal to minus 1. So, cos of log of iota raised to power iota, that will be equal to square root of 1 minus 1 square. We are saying this value, it is 1 minus sine square theta. So, it is equal to square root of 1 minus 1, that is equal to 0. So, we are getting that the value of sine of this term is equal to 0. Now, another way to solve this problem is that if we consider iota raised to the power iota, it is equal to this iota, we are writing it in the polar form. So, it is e raised to the power iota pi by 2 and whole raised to the power iota. So, it is equal to e raised to the power minus pi by 2. So, we can see that the value of iota raised to the power iota, that is equal to e raised to the power minus pi by 2. Now, if we substitute this value in the given equation, we will get it is sine of log of iota raised to power iota means e raised to the power minus pi by 2. So, that is equal to sine of minus pi by 2, and we have already seen that the value of sine of minus pi by 2, it is equal to minus 1, and then we can use this formula to obtain the value of cos of log of iota raised to the power iota. So, you can use any of these methods to obtain this result. Next question we have is find the general value of log to the base 2 5 iota. We have to find the general value of this term. So, this is base 2 over here, and we know how to change the base in terms of log. It is, we are writing in terms of base e, it is log base e 5 iota upon log base e 2, and the value of this term we will have, it is log base e mod of 5 iota plus, if we are talking about the general value, it is iota argument of 5 iota plus 2n pi, and it is divided by log 2 to the base e. So, it is equal to 1 by log 2 to the base e. What is mod of 5 iota? It is 5. So, we have it is log to the base e 5 plus argument of 5 iota. We are talking about 5 iota. So, 5 iota will lie over here somewhere on the imaginary axis. So, the angle we have over here, that is equal to pi by 2. So, we are getting it is iota pi by 2 plus 2n pi iota, where n belongs to integers. So, this is the value of log base 2 5 iota. This is the value of this term. Now, the next result we have is that amplitude of z minus amplitude of minus z is equal to plus minus pi. So, we are going to discuss two cases over here. First is if amplitude of z is positive. Amplitude of z is positive means we are talking about the complex number, it lies in the first quadrant. We are talking about the number we have over here, it lies in the first quadrant. In this case, we are saying that amplitude of z is positive. So, if the number z lies over here, so if we are talking about the number minus of z, the minus of z will be, we are saying if z is a plus iota b, then minus of z will be minus a. minus iota b, this is minus z we are saying. So amplitude of this number will be, now we are talking about the amplitude of this number, that will be minus of pi minus theta. The angle we require over here, it is in this direction, earlier this was in this direction. So it is minus of pi minus theta. We are not measuring the angle in this way, we are not writing it is pi plus something, because we know that the principal values, they lie between minus pi is less than theta is less than equal to pi. So we are measuring the angle in this direction. So we are having its value is minus of pi minus theta. So if we are calculating the value of amplitude of z, that is theta, and it is minus amplitude of minus z, it is plus pi minus theta, the answer we get it is equal to pi. And the second case we have is when amplitude of z we are taking it is negative. When amplitude of z is negative, z lies over here, it is negative, this theta is negative, it lies over here, minus z, it lies over here, the number at this place, that will be of the form a minus iota b, and the negative of this number will be of the form minus a plus iota b. So the amplitude over here, it is minus theta, and the amplitude at this place, that will be pi minus theta. If this angle is theta, then this angle will be equal to theta, and this angle will be pi minus theta. So we are getting the answer as amplitude of z is minus theta, and we are doing it is minus of amplitude of minus z is pi minus theta. So this answer comes out to be minus pi. So we are saying that amplitude of z minus amplitude of minus z, that is equal to plus minus pi, according as amplitude of z is positive or negative. Next is, if mod of z1 that is equal to mod of z2 and argument of z1 by z2 that is equal to pi, then we have to find the value of z1 plus z2. So as it is given that the argument of z1 by z2, this is equal to pi, so this implies us that argument of z1 minus argument of z2, this is equal to pi. We know this formula. So if we write the value of z1, we are writing that is equal to, we are writing it in polar form, it is mod of z1, and then it is cos of argument of z1 plus iota sine of argument of z1. We are getting this value. And similarly we have z2 is equal to mod of z2 cos of argument of z2 plus iota sine of argument of z2. Now if we substitute the values over here, we are talking about this z1 value, we are writing this is z1 is equal to mod of z1 into cos of argument of z1 we have, this is equal to pi plus argument of z2 plus iota sine pi plus argument of z2. So this is equal to mod of z1 into cos of pi plus argument of z2, this will be equal to minus cos of argument of z2, and this term will be minus iota sine argument of z2. Minus sign we take common, we are left with is mod of z1. In place of mod of z1 we can write it is using this condition, mod of z1 is equal to z2. So in place of z1 we are writing it is mod of z2 into cos of argument of z2 minus plus sine of argument of z2, and this is the value of this whole term we are talking about, its value is z2. So it is minus of z2. So what we get from this is, look at these terms over here, we have started with z1 and we obtain it is equal to minus of z2. So the final answer we obtain is that z1 plus z2 is equal to 0. So this is the value of z1 plus z2. Next is, let z and w be two non-zero complex numbers such that mod of z is equal to mod of w and argument of z plus argument of w that is equal to pi. We have to find the relation between z and w. Similar question we have already done in our previous slides. So from this we can write it is argument of z that is equal to pi minus argument of w. So if I write the value of z, that will be mod of z into cos of argument of z plus iota sine of argument of z. In place of mod of z, we can write it is mod of w, and in place of argument of z, we can write pi minus argument of w. So this will become minus cos argument of w, and this term will become plus iota sine argument of w. This is equal to minus sign we have taken common, modulus of w into cos of argument of w minus iota sine argument of w. This is equal to minus modulus of w, then it is cos of argument of w plus iota sine argument of w and whole conjugate. Now look at this term over here, we are talking about this value, it is mod of w into this term. So this is equal to, this term is equal to minus this whole term, we are saying it is conjugate of w. So what we obtain from this relation, that z is equal to minus conjugate of w. So this implies us that z plus w conjugate is equal to 0. So this is the relationship between z and w. Next we are going to solve certain problems related to the complex equations. So the first is, we have to solve this equation, it is z square plus mod of z is equal to 0. So if we substitute z is equal to x plus iota y in this equation, we will obtain it is x square minus y square plus 2 iota xy plus mod of this term will be x square plus y square square root, this is equal to 0. So if we equate the real part, we get it is x square minus y square plus square root of x square plus y square is equal to 0, and when we equate the imaginary part, we obtain it is 2xy is equal to 0. So this implies us either x is equal to 0 or y is equal to 0. So we solve this equation in two parts. One is we are considering when x is equal to 0, second we are considering when y is equal. So solving this first part, we obtain when we substitute x is equal to 0, we get it is minus y square. Over here we obtain it is minus y square plus mod of y is equal to 0, and when we substitute y is equal to 0, we get x square plus mod of x is equal to 0. Why mod of x? Because we know that square root of x square is equal to mod of x and square root of y square is equal to mod of y. Now this first equation, if we are talking about, it gives us, we are talking about this equation, we are saying we can write it as minus mod of y square plus mod of y is equal to 0. So if we take mod of y common, we are left with is 1 minus mod y is equal to 0. So this thing implies us that mod y is equal to 0 or mod of y is equal to 1. So this implies us y is equal to plus minus 1. For the second part, we have mod of x square plus mod x is equal to 0. So if we take mod x common, we are left with is mod x plus 1 is equal to 0. and clearly the answer we have, it is mod x is equal to 0, because this part mod of x plus 1 is equal to 0, it cannot have any solution because mod x is positive. We cannot add 1 to any positive number to get the answer 0. So, we have the value x is equal to mod of x is equal to 0, that is x is equal to 0. So, the numbers that are formed from this, it is 0 only, and numbers that are formed from this first part we are talking about, there we are having the value of x is equal to 0, y is 0 and plus minus 1. So, it is 0, iota and minus iota. So, the final answers we obtain over here, it is z is equal to 0, iota and minus iota. These are the solutions of the given equation. Next is find the number of solutions of the equation z square plus mod z square is equal to 0. So, this equation, we can write it in the form z square plus z into z bar is equal to 0. So, this becomes z into z plus z bar is equal to 0. So, this gives us two cases, either z is equal to 0 or we get z plus z bar is equal to 0. So, z plus z bar, we know this is basically real part, 2 times real part of z is 0, it means real part of z is equal to 0. So, this implies us the value of z that can have, that is equal to iota y. So, how many solution? Either z is equal to 0 or we are saying z is of the form iota y. So, the number of solutions we have, it is infinite solutions, because for all real values of y we have solution z is equal to iota y. Next is find all complex numbers satisfying this equation. So, the equation given to us is, it is 2 mod of z square plus z square minus 5 plus iota root 3 is equal to 0. So, if we substitute z is equal to x plus iota y, if we substitute z is equal to x plus iota y, this equation will become 2 times x square plus y square, then it is plus z square, this will become plus x square minus y square plus 2 iota xy minus 5 plus iota root 3 is equal to 0. So, if we equate the real and imaginary parts over here, the real part is 2 times x square plus y square, this term if we look at, it is plus x square minus y square minus 5 is equal to 0, and the imaginary part we have over here, it is 2xy plus root 3 is equal to 0. So, this first equation we have, this equation will become 3x square minus y square minus 5 is equal to 0. This is 3x square, 5 is equal to 0. Now, we have to solve these two equations. To solve these equations, we are calculating the value of x from here. So, that will become minus root 3 by 2y. We substitute this value in this equation, we get it is 3 into 3 by 4y square minus y square minus 5 is equal to 0. So, this equation gives us, when we multiply these values, we obtain it is 9 by 4 y square, then it is minus 4y raised to the power 4, and then it is minus 20y square, that is equal to 0. So, the equation we obtain from this is 4y raised to the power 4 plus 20y square minus 9 is equal to 0, and we can factorize this as 2y square minus 9 into 2y square minus 1 is equal to 0. We are talking about this equation over here. And on solving this equation, we obtain the values of y. On solving this equation, we obtain the values of y, and when we substitute these values of y, in the values of x, we obtain different values of x. So, these are the values of x corresponding to these values of y. So, the numbers we obtain, the final answer we obtain, it is in this form. These are the solutions of this quadratic. These equation, of this given equation. Now next we have is the De Moivre's theorem. So we are saying if we have the numbers, the real numbers we are talking about, it is theta 1, theta 2, so on up to theta n, and we are calculating the value of cos of theta 1 plus iota sine of theta 1. We are talking about this first value. We are multiplying it with cos of theta 2 plus iota sine theta 2. Then it is cos of theta 3 plus iota sine theta 3. Then so on up to cos of theta n plus iota sine theta n. If we are multiplying these terms, the answers we obtain, it is cos of sum of all these angles plus iota sine of sum of all these angles. Next, this result can be extended in this way. We are saying that theta belongs to R again, and if n is the set of integers, in this case if we put theta 1 equal to theta 2, so on up to equal to theta n is equal to theta, this result can be written in the form cos of theta plus iota sine theta raised to the power n, that is equal to cos n theta plus iota sine n theta. In this case, the value of n that we have, that is the natural number. The value of n we have, it is natural number. Now we are talking about if this result also holds if the set, this n belongs to the set of integers, and this result also holds if n belongs to the set of rational numbers. So we are talking about the powers over here. So if either it is natural number, integer or rational number, this result holds. So coming to proof of this result. So the first part we are going to prove, it is, we are saying that the value we are calculating over here, it is cos of theta 1 plus iota sine theta 1 into cos of theta 2 plus iota sine theta 2. So we can write using the Euler's formula, we can write it is e raised to the power iota theta 1, e raised to the power iota theta 2, so on up to e raised to the power iota theta n, and this is equal to e raised to the power iota theta 1 plus theta 2, so on up to theta n, and this is equal to cos of theta 1, so on up to plus theta n plus iota sine of theta 1, so on up to theta n, and this is what we have to prove. And we have already seen that if we substitute theta 1 is equal to theta 2 is equal to theta n, then these values will become same. So these are basically the multiplication of the n factors. So we can write this in the form that cos theta plus iota sine theta raised to the power n, that is equal to cos n theta plus iota sine n theta. Here n belongs to n is belongs to the set of natural numbers. Now we extend this result for the rational number. So we are substituting this n is equal to p by q, where q is not equal to 0 and p and q, these are the integers. So what we are talking about is that cos of p by q times theta plus iota sine of p by q theta whole raised to the power q, that will be equal to cos of p by q theta into q plus iota sine p by q theta into q. So this is equal to cos of p theta plus iota sine of p theta. So this is just, we are saying this time when we look at what we are trying to say is that if we have a raised to the power some number, say q, that is equal to b, so then what this thing implies is, this thing implies that a is one of the values of b raised to the power 1 by q. A is one of these values. I am again explaining this thing. We are saying that if 2 raised to the 3 raised to the power 2, we are writing that is equal to 9. So this thing means that 3 is one of the values of 9 raised to the power 1 by 2. So similarly we are saying that cos of p by q theta plus iota sine of p by q theta is one of the values of cos p theta plus iota sine p theta raised to the power 1 by q. Look at this power over here, it is q. Look at this term over here. We are combining these two values and we are writing it in this form. Now, this result we are saying, this can be written as cos theta plus iota sine theta raised to the power p by q. The power p can come over here. So we are saying that this is one of the values of cos theta plus iota sine theta raised to the power p by q. This is what we have to prove, that this term is one of the values of this value. So some other forms of De Moivre's theorems are given over here. The first is that if cos theta minus iota sine theta raised to the power n is there, then the answer will be cos n theta minus iota sine n theta. Next is if we have sine theta plus iota cos theta raised to the power n. We can write this is equal to, if we take iota common, we get it is cos theta minus iota sine theta raised to the power n. This is equal to iota raised to the power n into cos n theta minus iota sine n theta. This is our second result. Similarly, third will be, the third result we are saying it is sine theta minus iota cos theta raised to the power n. The answer will be in this form. Next is cos theta plus iota sine phi raised to the power n. Now look at these terms carefully. It is angle theta over here and angle phi over here. So we are saying that this is not equal to, we cannot use the formula in this way, that it is cos of n theta plus iota sine of n phi. This result does not hold. And the last part we have is that 1 over cos theta plus iota sine theta, we can write this is equal to cos theta plus iota sine theta raised to the power minus 1. It is power minus 1 is there, so minus 1 is shifted inside. We get it is equal to cos theta minus iota sine theta. The same result we have also proved previously with the help of 1 over cos theta plus iota sine theta. We have multiplied and divided it with cos theta minus iota sine theta and divided it with cos theta minus iota sine theta, and we obtain this result. The denominator over here, that will become cos square theta plus sine square theta, that is equal to 1, and we obtain this answer. Next is, it is given that ZR, that is equal to cos of pi by 3 raised to the power r plus iota sine pi by 3 raised to the power r. We have to prove that Z1 into Z2 so on up to infinity, that is equal to iota. So if we multiply these terms, we are saying we are writing Z1, that is cos of pi by 3 plus iota sine pi by 3, that is equal to e raised to the power iota pi by 3. We are talking about Z2, that will be e raised to the power iota pi by 3 square, and so on. If we multiply these terms, the answer we will get it is Z1 into Z2 so on. This is equal to e raised to the power iota pi by 3 plus pi by 3 square plus pi by 3 cube and so on. This is equal to e raised to the power iota. This is a GP, infinite GP. First term is pi by 3 and common ratio is 1 by 3. We are talking about the common ratio over here. It is pi by 3 square by pi by 3, that is equal to 1 by 3. So on solving this, we will obtain it is equal to e raised to the power iota pi by you solve this value, you will get it is 2 by 3. So this is e raised to power iota pi by 2. So that is equal to cos pi by 2 plus iota sin pi by 2, and this is equal to iota, and this is what we have to prove. Next is express this number in the form a plus iota b. So it is cos theta plus iota sin theta. We can write it is e raised to the power iota theta raised to the power 4 divided by, it is sin theta plus iota cos theta. We are talking about this term, it is sin theta plus iota cos theta. If we take raised to the power 5, if we take iota raised to the power 5 common, we are left with this cos theta minus iota sin theta raised to the power 5. What is iota raised to the power 5? It is iota, and this term we can write it is e raised to the power minus iota theta raised to the power 5. So this term will become iota e raised to the power minus iota theta raised to the power 5. So it is e, if we take iota over here, it is minus iota into, in the numerator we have shifted, it becomes minus iota e raised to the power iota 4 theta plus iota 5 theta. So this is equal to minus iota e raised to the power iota 9 theta. This is equal to minus iota into cos 9 theta plus iota sin 9 theta, and this is equal to minus sin 9 theta. This will become minus minus will, when you multiply iota square it will become minus 1. So this will be plus sin 9 theta minus iota cos 9 theta. So this is the final answer that we obtain. It is sin 9 theta minus iota cos 9 theta. So this is of the form a plus iota b. Now next we have to find the roots of any complex number. Suppose first we are talking about the case a plus iota b raised to the power 1 by 2. I am talking about a simpler case over here. The power is 1 by 2. Now in this case, if suppose this number is a real number, we are talking about the number say 4, and we are saying its power is 1 by 2, the answers we know that it is plus minus 2. So how we are going to find the roots of this complex number? We are saying we write this number a plus iota b in the form r into cos theta plus iota sin theta. We are writing it in this form. If I am talking about this number, we can write this 4 is equal to 4 into cos 0 plus iota sin 0. Now we have to take its root. We are talking about the power over here, it is 1 by 2, this whole raised to the power 1 by 2. So the answer we get in this case, it is 2 times cos 0 plus iota sin 0 raised to the power 1 by 2. So what we are saying over here, it is r raised to the power 1 by 2, r is a real number, into cos theta plus iota sin theta raised to the power 1 by 2. Now by De Moivre's theorem we know that this is equal to 2 into, I am explaining you why this plus minus 1 2 is there, why not only plus 2 is there. We are saying cos of theta by 2, that is 0 by 2, plus iota sin of 0 by 2 is one of its roots. Why we are writing it's one of its roots? What are its other roots? The question is, the answer we get over here, it is 2 times 1, that is equal to 2. So this is one of its roots. So now the question arises is that what are its other roots? From where we are getting those roots? So we are saying that if we look at this number, the angle we are talking about, it is theta is equal to 0. We can write this is equal to 2 times cos of 2n pi plus iota sin of 2n pi raised to the power 1 by 2, because cos of theta, that is equal to cos of 2n pi plus theta, and sine of theta, that is equal to sine of 2n pi plus theta. Now, if we shift this power inside, we use the de Moivre's theorem now, the answer we get it is 2 times cos of n pi plus iota sine of n pi. What are the values of n over here? We can substitute n is equal to n belongs to, we are saying it is set of integers. Now, if we substitute different values of n, if we substitute n is equal to 0, I am talking about the case, if we substitute n is equal to 0, we obtain this first answer, we are obtaining one of its roots. Next, if we substitute n is equal to 1, I will obtain the answer. If we substitute n is equal to 1 in this, we will obtain it is 2 times cos pi plus iota sine pi, and the value I will obtain it is minus of 2. So, this is why we are getting plus minus 2 over here. Now, if we substitute n is equal to 3, next if we substitute n is equal to 3, the answer I will get, that will be 2 cos 3 pi plus iota sine 3 pi. Look at this value 3 pi. This is not the principal value. So, to convert it to the principal value, the answer will again become equal to, it is 2 times cos of pi plus iota sine of pi. So, again the answer we will get, that will be equal to minus 2. So, we are getting the answers as plus 2, minus 2, plus 2, minus 2 if we substitute the values of n belonging to I. Now, similar is the case over here. Similar thing we are talking over here, that this is, if we write the answer from this term, we will get only one answer. We will get only one root. So, to find the general values of this root, we have to write in place of this theta, we are going to write it is 2n pi plus theta. In place of this theta, we are going to write 2n pi plus theta. And when we divide it with the 2, we will obtain all the roots by substituting different values of n. So, same thing we are talking over here for this general case. We are saying we have the number a plus iota b raised to the power p by q. A plus iota b, we are writing it is cos r times cos of 2n pi plus theta sine of 2n pi plus theta. After this, we have used the de Moivre's theorem and we obtain the answer in this form, that we have multiplied this power inside the angle. We are saying this power p by q, it is multiplied over here, and the value of n that can vary, it is this. You can write in place of this, you can write that n belongs to I. But what will happen in this case? After the value q minus 1, it means we are saying when we substitute n is equal to q, it will have the same answer whatever I am getting for n is equal to 0. So, basically we are substituting the values of n is equal to 0, 1, 2, 3, so on up to q minus 1. So, what we are saying is that the number of roots of this equation is q. We obtained q different roots for this particular equation. So, based upon this, we are going to solve certain problems. So, first is x raised to the power 5 minus 1 is equal to 0. We have to solve this. So, we can write this equation as x is equal to 1 raised to the power 1 by 5. Now, clearly this power over here, it is 5 over here. So, there will be 5 different roots. And to find these roots, we are going to write this 1 in the polar form, and the polar form for 1 we have, that is equal to r is 1, it is cos of 0 plus iota sine of 0. Now, we write it in the Mohn journal answer, it is cos of 2n pi plus iota sine of 2n pi. Now, if we take power 1 by 5, if we take power 1 by 5, we get this is equal to cos of 2n pi by 5 plus iota sine of 2n pi by 5, and the values of n, they will vary from 0, 1, 2, 3 and 4. So for n is equal to 0, the first answer we will obtain it is cos 0 plus iota sin 0. Next is cos, when we substitute n is equal to 1, we get it is 2 pi by 5 plus iota sin 2 pi by 5. Next is cos, we substitute it 2, it is 4 pi by 5 plus iota sin 4 pi by 5. Then it is cos, we substitute 3 over here, it is 6 pi by 5 plus iota sin 6 pi by 5. Then it is cos, we substitute 8 pi by 5 plus iota sin 8 pi by 5. Now look at these values over here. When we are saying 6 pi by 5, 6 pi by 5 means, when we are talking about 6 pi by 5, so that is equal to 2 pi plus 4 pi by 5. So this value will become cos of 4 pi by 5 minus iota sin 4 pi by 5. And similarly this value 8 pi by 5, this will be, this 8 pi by 5, we can write this is 2 pi minus 2 pi by 5. So if we substitute this value over here, the answer we will get it is cos of 2 pi by 5 minus iota sin 2 pi by 5. So the final answers we are getting over here, this is 1, this is cos of 2 pi by 5 plus minus iota sin 2 pi by 5, and this will give us cos 4 pi by 5 plus minus iota sin 4 pi by 5. So these are the values because of which this negative sign is coming over here. So these are the 5 roots of unity. These are the 5 roots of unity. Next is we have to find all the roots of this equation. It is x raised to power 6 minus x raised to power 5 plus x raised to power 4. So if we look at this equation, divide these values over here, we are writing it is a GP whose common ratio it is, you can write this equation in the form 1 minus x plus x square minus x cube plus x4 minus x5 plus x6. So the common ratio we have over here, it is minus x by 1, that is equal to minus x, and the sum of this GP will be, first term is 1, it is 1 minus minus x raised to the power 7 divided by 1 minus minus x, and we are saying that this is equal to 0. This equation becomes this, and this term we are saying it will become 1 plus x, and this whole term we are saying this will become 1 plus x raised to the power 7. So this implies us that 1 plus x raised to the power 7 that is equal to 0, and the denominator over here 1 plus x, it cannot be equal to 0, it means x cannot be equal to 1. So we have to find the value of 1 plus x raised to the power 7 is equal to 0. So this implies us x raised to the power 7 is equal to minus 1. So it means we have to solve the equation x is equal to minus 1 raised to the power 1 by 7, and another condition we have over here is x is not equal to minus 1. So we have to find the 7th root of minus 1. We can write this minus 1 is equal to cos of 2n pi plus pi plus iota sin of 2n pi plus pi. When we have to take the 7th root over here, these values will be divided by 7, and the values of n will vary from 1, 2, 3, 4, 5 and 6. So the answers we will have, that is equal to cos of 2n plus 1 by 7 pi plus iota sin of 2n plus 1 by 7 pi, and these are the values of n that we can have. So these are the 7 roots of minus 1. Next is cube roots of unity. So we are saying that if we are having z is equal to 1 raised to the power 1 by 3, we already know that when we are talking about the real numbers, then we have x cube is equal to 1. This implies x is equal to 1. But now we are talking about the complex numbers and we are solving z is equal to 1 raised to the power 1 by 3. So this 1 we can write it is equal to cos of 2n pi plus iota sine of 2n pi, and it is power is 1 by 3. So and the value of n, they vary from 0, 1 and 2. So if we substitute these values over here, we will obtain it is cos of 2n pi by 3 plus iota sine of 2n pi by 3. So when we substitute n is equal to 0, we get it is cos 0 plus iota sine 0. When we substitute 1, we get it is cos 2 pi by 3 plus iota sine 2 pi by 3. And when we substitute 2, we get it is cos 4 pi by 3 plus iota sine 4 pi by 3. And if we solve these values, we obtain 3 answers in this form. That is, these roots are 1 minus 1 plus iota root 3 by 2 and minus 1 minus iota root 3 by 2. So these roots we can also write in the form 1 e raised to the power 2 pi iota by 3 e raised to the power 4 pi iota by 3. Another way to solve this equation is, we are writing it is z cube minus 1 is equal to 0. So this implies us that z minus 1 into z square plus z plus 1 is equal to 0. So this implies us z is equal to 1 or z square minus plus z plus 1 is equal to 0, and this quadratic equation will have the roots z is equal to minus 1 plus minus square root of minus 3 by 2. So that is equal to minus 1 plus minus iota root 3 by 2. So we have 3 roots of unity. 1, then next is minus 1 plus iota root 3 by 2, and next is minus 1 minus iota root 3 by 2, and these 3 roots, they can be written as 1, this second root is written as omega, and this third root is written as omega square. These are just the notations we are talking about, that these roots, they can be written as 1, omega and omega square. So you can use any of these methods to calculate the roots, cube roots of unity. Now based upon this, we have 10 results over here. The first is that omega bar is equal to omega square and omega bar square is equal to omega. Now the value of omega bar that we have, it is minus 1 plus iota root 3 by 2, and if we take the conjugate of this number, we get this is equal to minus 1 minus iota root 3 by 2, and this is the value omega square. And if we square this term, talking about the second part over here, we are saying omega bar is equal to omega square. If we square these terms, this will become omega raised to the power 4. This is equal to omega cube into omega. And what is omega cube? We are saying 1 raised to the power 1 by 3 is basically one of the values is omega. So it means omega cube will be equal to 1. So the answer, this omega cube is equal to 1. So the answer we get it is equal to omega. So we are saying that omega bar square is equal to omega. Next we have square root of omega is plus minus omega square. We are saying that square root of omega is plus minus omega square, and square root of omega square is plus minus omega. Substituting these values, you can verify these results. Next is mod of omega, that is equal to mod of omega square, that is equal to 1. So the number we have, it is we are talking about the number omega, we have it is minus 1 by 2 plus iota root 3 by 2. So if we calculate the mod of omega, the answer we get it is 1 by 2 square plus 3 by 2, 3 by 4 and whole square root. So the answer we get it is equal to 1, and we have omega bar is equal to omega square. So mod of omega bar will be omega square and these value will be equal to omega. So we can prove this result using this. Next is 1 plus omega square is equal to 0. So if we are talking about this value, we are saying it is 1 plus minus 1 by 2 plus iota root 3 by 2 plus minus 1 by 2 minus iota root 3 by 2. Clearly the value we have, that is equal to 0. So we have 1 plus omega square is equal to 0. Then we have is omega cube is equal to 1. This thing we have already seen, that omega cube is equal to 1. So if omega cube is 1, we are saying that omega raised to the power 3n is equal to 1. Omega raised to the power 3m plus 1 will be omega, and omega raised to the power 3m plus 2 will be equal to omega square. This is just like the properties of, as we have studied the properties of iota, these are the properties, similar properties for the omega. Now next we are saying that 1 plus omega raised to the power n plus omega raised to the power 2n, this will be equal to, we are saying if n is a multiple of 3, then all these values will become 1 plus 1 plus 1 and the answer will be equal to 3, because we are saying when n is multiple of 3, then omega raised to the power 3 times some r, that will be 1. Similarly omega raised to the power 2 into 3 times r, that will be equal to 1. So all these values, these are equal to 1, and the sum of these values, that will be equal to 3. And the second case we are saying if n is not a multiple of 3. So if it is not a multiple of 3, then it means that it can be of the form, we are saying this, I am talking about the value omega raised to the power n. It can be of the form omega raised to the power 3r plus 1 or omega raised to the power 3r plus 2. We are saying then this number n, we are saying this is of the form 3r plus 1 or it is of the form 3r plus 2. So if we are talking about this case, the value of 2n will be 6r plus 2, or 6r plus 2 means it is 3r plus 2, and this value will be 3r plus 1. So what we will get, this number will become 1 plus omega raised to the power 3r plus 1 plus omega raised to the power 3r plus 2. So this is equal to 1 plus omega. Why? We are writing omega raised to the power 3r plus 1 means omega raised to the power 3r into omega, and omega raised to the power 3r means 1. Similarly this value will become omega raised to the power 3r into omega square. This value is 1, so we are left with this omega square, and the final answer 1 plus omega square, we know it is 0. So we are saying that if it is not a multiple, n is not a multiple of 3, in this case the answer will be 0. The next result we have is that the cube roots of minus 1 are, if we have to calculate the cube roots of minus 1, they are minus 1 minus omega and minus omega square. And the last result we are talking over here, it is if we have a, b, c, these are three real numbers, a, b, c, these are real numbers, and we are having the equation a plus b omega plus c omega square, that is equal to 0, then this thing is only possible if a is equal to b is equal to c. We are saying that a plus b plus c, a plus b omega plus c omega square is equal to 0. This implies a is equal to b is equal to c. But this condition is important over here, that all these three a, b, c, these are the real numbers. Next we have is the representation of the cube roots of unity on the complex plane. So we are saying we have represented it over here. Look at this value, look at this graph. We are saying the number 1 we are talking about, this number 1, it is over here. Then the cube roots of unity we are saying, their modulus, the modulus of all 1, omega and omega square we are saying, the mod of all these numbers, the modulus of these numbers, that is equal to 1. It means they will lie on the unit circle, and the angles they will form, the angle they are forming over here, it is this point, it is omega, this point it is 1, and this point it is omega square. And if we join these 3 points, we are getting a triangle, and we are saying that all these 3 points, they are lying on the unit circle. We are talking about this is mod of z is equal to 1, this is this circle, they are lying on this circle, and this thing is written over here, that the cube roots of unity when represented on the complex plane lie on the vertices of an equilateral triangle inscribed in a unit circle having the center at origin and one vertex being on positive real axis. So this is the graphical representation of cube roots of unity. Next we have is, if we have to solve the equations, we should remember these formulas that we have now. First is, if we have the equation of the form a square plus ab plus b square, then the formula we have for this, it is a minus b omega into a minus b omega square. You can verify this result, you can multiply these values, you will get it is a square minus ab omega square minus b omega a plus b square omega cube. So this will give us a square, we take minus ab common, we are left with this omega plus omega square plus b square omega cube is equal to 1. Now what is value of omega plus omega square? We have 1 plus omega square is equal to 0. So omega plus omega square, this value will be equal to minus 1. So the answer we are getting, it is a square plus ab plus b square. So this is our first result. Second is, it is minus sign over here, it is minus ab over here. So the formula, it is in this form. Next is a cube plus b cube. So when we are talking about a cube plus b cube, we know the formula we have, it is a plus b into a square minus ab plus b square, and the formula for a square minus ab plus b square we have seen. So the result we get is a plus b omega into a plus b omega square. Similarly, if we have negative sign over here, this term will become negative, this will become positive. So both these terms will become negative. Next formula we are saying, it is a square plus b square plus c square minus ab minus bc minus ca, that is equal to this value. You can verify this by multiplying these terms. And the last formula we have over here, it is a cube plus b cube plus c cube minus 3abc, that we can write it is a plus b plus c into a plus b omega plus c omega square into a plus b omega square plus c omega. So if you will multiply these terms, you will obtain the answer as a cube plus b cube plus c cube minus 3abc. Now next we are going to solve certain problem based upon these. So first is, if omega is non-real cube root of unity, this non-real is important over here, we have to find the value of omega raised to the power 1999. We know that we have to divide 1999 by 3. So when you will divide this number, you will get 666 as quotient and 1 as remainder. So we can write it is omega into 3 into 666 plus 1. So this is equal to omega, because this you can write it is omega raised to the power 3 raised to the power 666 into omega, and omega raised to the power 3 we have, that is equal to 1. So the answer we are left with is omega. Next we have is this value we are having over here, it is omega. Next is omega raised to the power minus 998. We are saying it is 1 over omega raised to the power 998. Now we want to change this term to the power multiple of 3. So we are multiplying it with omega, dividing it with omega. So this will become 1 by omega raised to the power 999. Omega in the numerator. This is a multiple of 3. So answer is equal to 1. So this value we get, this is equal to omega. This value we are getting, it is equal to omega. Next is minus 1 plus iota root 3 by 2 raised to the power 3n plus 2. Look at this value carefully. This is the value for omega. So we are being asked omega raised to the power 3n into omega square. So that will be equal to omega square, because it is a multiple of 3. Power is multiple of 3. So this will be equal to 1. So answer we are getting, it is omega square. Next is 1 plus omega square, and we have to multiply it up to 2n factors. So if we are multiplying these values, we are writing it is 1 plus omega, then it is 1 plus omega square. Next is 1 plus omega raised to the power 4. What is omega raised to the power 4? That is equal to omega cube into omega, that is equal to omega. So it is 1 plus omega. Next is omega raised to the power 8, that is equal to omega raised to the power 6 into omega square. So that is equal to omega square. So next value we have 1 plus omega square. Likewise we have 2n factors. Now what is value of 1 plus omega? We have 1 plus omega square is equal to 0. So 1 plus omega is minus omega square, and 1 plus omega square is minus omega. So what we are getting over here is this value is equal to minus omega square. This value is minus omega square minus omega, so on up to 2n factors. So how many times this term minus omega square is there? It is n times. How many times this minus omega is there? It is n times. So we are writing this negative sign will be cancelled out. We are left with this. In place of this, we are going to do is this. Look at these two terms. It will become omega cube. Then next these two terms, these will become omega cube. So we are saying that we have now 1 into 1 into 1, so on up to n times. So the answer we obtain for this, that is equal to 1. Next is, if alpha, beta and gamma are the roots of this equation, we have to find the value of alpha minus 1 by beta. I'm talking about this minus 1, then beta minus 1 by gamma minus 1, then gamma minus 1 by alpha minus 1. If we try to solve this equation, we are having x cube minus 3x square plus 3x plus 7 is equal to 0. We can write, look at this term over here. It is x cube minus 3x square plus 3x. We are writing it is minus 1 plus 8 is equal to 0, and this is the formula for x minus 1 cube plus 2 cube is equal to 0, and the formula for a cube plus b cube, we know it is x minus 1 plus 2 into x minus 1 plus 2 omega, then x minus 1 plus 2 omega square is equal to 0. So we get the values of x is equal to 1, minus 1 we are saying, and the next value of x we will obtain, that is will be equal to 1 minus 2 omega, and the next value we obtain, it is 1 minus 2 omega square. These are the three values we are obtaining for x. So these are the roots we are saying. This is alpha, beta and gamma. So if we substitute these values in this formula, we will obtain it is alpha minus 1, that will become minus 2 by beta minus 1. So the value of beta minus, we are saying alpha minus 1 is minus 2, beta minus 1, that will be equal to minus 2 omega, and gamma minus 1, that will be equal to minus 2 omega square. So the answer we are getting, it is minus 2 by minus 2 omega plus minus 2 omega by minus 2 omega square plus minus 2 omega square by minus 2. So these values gets cancelled. We are left with is 1 by omega plus 1 by omega plus omega square. Now if we multiply these terms with omega square divided with omega square, we are multiplying it with omega square divided with omega square. This implies us this term will become omega cube, it is 1. So we are getting omega square plus omega square plus omega square. So the answer we are getting, this is equal to 3 times omega square. So this is the final answer that we have. This is the value of this term. Next is if z is equal to root 3 plus iota by 2. You are saying z is equal to root 3 plus iota by 2. This is not equal to omega. The value of omega that we have, that is minus 1 plus iota root 3 by 2. This is the value of omega that we have. We have to find the value of z raised to the power 101 plus iota raised to the power 103 whole raised to the power 105. So we have to convert this number to this form. So we can write this is z is equal to, if I divide and multiply this number by iota, I am dividing and multiplying this number by iota, I will get it is this value will become, iota square will become minus 1 plus iota root 3 by 2, and in the denominator we have iota, so we can write it is minus iota over here. This denominator number we are writing over here. So we are saying that z is equal to minus iota omega. Now we have to calculate the value of minus iota omega raised to the power 101 plus iota raised to the power 103 whole raised to the power 105. So look at this term over here. If you look at this term over here, it is minus iota raised to the power 101 omega raised to the power 101 plus iota raised to the power 103 and whole raised to the power 105. Now iota raised to the power 101, that will be equal to minus iota raised to the power 100 plus 1 omega raised to the power 99 plus 2 plus iota raised to the power 100 plus 3 whole raised to the power 105. So this is equal to minus iota omega square plus iota cube whole raised to the power 105. What is iota cube? It is minus iota. The value of iota cube we have, that is equal to minus iota. So it is minus iota omega square minus iota raised to the power 105. So if we take minus iota raised to the power 105, we are left with this omega square plus 1 raised to the power 105. Now 1 plus omega square is equal to minus omega. This 105 when we are writing, we can write it is 104 plus 1. So this term will become minus iota. This term we are talking about omega square plus 1, that is equal to minus omega, and minus omega raised to the power 105, it is a multiple of 3. So the answer we will have, it is minus 1. So the final answer that we obtain, that is equal to iota. The final answer in this case we get, it is iota. Now next we have is 3 by 2 plus iota root 3 by 2 raised to the power 50. That is equal to 3 raised to the power 25 into x minus iota y. We have to calculate the value of x and y. Now look at this number over here. The value of omega we have, it is minus 1 plus iota root 3 by 2. The number we have over here, it is 3 by 2 plus iota root 3 by 2. So if we take 2 common, we are having 3 plus iota root 3. Now if we write root 3 common from this, we get it is root 3 plus iota by 2. Now we have to convert this number into this form. So we are going to multiply and divide it by iota. So we get this is equal to minus iota root 3. This iota we are shifting over here. And this term, when we are multiplying iota inside, we are left with this iota into iota, that will become minus 1 plus iota root 3 by 2. So we are saying that this number, this is basically minus iota root 3 omega. So we are writing minus iota root 3 omega raised to the power 50, that is equal to 3 raised to the power 25 into x minus iota y. It is power 50, so this term will become positive. We get it is iota raised to the power 50, 3 raised to the power 25, omega raised to the power 50 is equal to 3 raised to the power 25 into x minus iota y. These two terms gets cancelled, and iota raised to the power 50, this will be equal to iota square, that will be equal to minus 1, and omega raised to the power 50, that will be equal to omega square. And the value of omega square that we have, it is minus 1 minus iota root 3 by 2, and it is being multiplied with minus 1, and that is equal to x minus iota y. So this term will become 1 plus iota root 3 by 2, that is equal to x minus iota y. So what we obtain is that x is equal to 1 by 2 and y is equal to minus root 3 by 2. These are the values that we obtain over here, that x is equal to 1 by 2 and y is equal to minus root 3 by 2. So the ordered pair we have to write x comma y, it has this value. Next is, if the polynomial 7x cube plus ax plus b is divisible by this polynomial, then we have to find the value of 2a plus b. So if this polynomial is divisible by this, it means the roots of this polynomial will satisfy this equation. Now the roots x square minus x plus 1, we are saying the roots of this polynomial, they are x plus omega into x plus omega square. We know this result. Otherwise what you have to do, you have to solve this quadratic equation and you will find the roots in terms of omega and omega square. So we are saying that the roots of this equation, they are minus omega and minus omega square. Now these roots should satisfy this equation. Suppose we are writing this is equal to f of x. So we get f of minus omega, that is equal to 7 times minus omega cube plus a times omega plus b is equal to 0. And we have f of minus omega square, that is 7 times minus omega square cube plus a times minus omega square plus b is equal to 0. And this is minus omega over here. So solving these two equations, from this first equation we will have omega cube is 1, so it is minus 7 minus a omega plus b is equal to 0. From this second equation we will have minus 7, then it is minus a omega square plus b is equal to 0. Now if we add both these equations, we will get minus 14 minus a into omega plus omega square plus 2b is equal to 0. And what is omega plus omega square? That is equal to minus 1. So this implies us, so minus minus will become plus. This implies us minus 14 plus a plus 2b that is equal to 0. So what we get from this is, this gives us that the value of a plus 2b that is equal to 14. Now if we subtract these two equations, I am talking about these two equations, if we subtract these two equations, this is plus over here, this will be plus, this will be minus. So the answer we will get it is minus a omega plus a omega square. We are saying that will be equal to 0. So this implies us a common, it is minus omega plus omega square is equal to 0. Minus omega plus omega square is not equal to 0. So we are getting a is equal to, this thing implies us a is equal to 0. And if we substitute this value of a over here, if we substitute the value of a over here, this thing implies us that b is equal to, a is equal to 0 we have. So the value of b we have it is 7. Now we need to find the value of the term 2a plus b. We are talking about what we have to calculate. We have to calculate the value of the term 2a plus b. The value of a we have calculated, it is equal to 0. The value of b we have calculated, it is 7. So the value of 2a plus b we obtain, it is equal to 7. So this is the final answer that we obtain in this case.